Hello and welcome to another LeetCode video. So today we're going to be doing the last part of the random problem challenge, and let's try to get a medium problem. That's not SQL. Spiral matrix 2. Okay, did we do this? No. Given position integer, generate a n by n matrix filled with elements from 1 to n squared. Okay. In spiral order. So generate. Oh, I see. So they want us, so we're given an integer. Okay, perfect. Okay. I think this is straightforward enough. Yeah. Yeah. I think so. Okay. So let's, first of all, if we're given an integer n, what are our dimensions of our matrix? Let's just start that. And so that's going to be, so if we're given 3, it's a 3 by 3, right? And so on. Yeah, okay. So matrix equals 0, which is 0 times n. So that's one row, right? And then this is going to be another one. Or we can just do so we can just do it another way, actually. 0 for I or for this in range n. And then for the in range n. Okay, I think this works for a, let me just print this. I think this should work. I'm like 99% confident. Yeah. Okay, so now that we have the matrix, so what we're actually going to be doing is we're going to start at the top left, and then every time we hit a wall, we're going to like go to another direction, and then we stop once we hit yeah, so we also need to turn, so we need to turn in a couple of cases, right? We need to turn if we hit a wall, or if we hit a value that we've already seen. So like we're gonna start off going right, we're gonna hit a wall, we're gonna go down, hit a wall, hit a wall, and then here we're gonna go up and we're gonna hit a value we've already seen. And then here, yeah, and then we end once our matrix is full. We can just have some kind of variable for that. So let's just call that cells or something. Okay, and let's just let's do the rows and the columns here. So we only need rows technically. So this is just going to be len, or this is going to be n. We don't even need rows, right? Because we can just use n directly. Okay, so filled cells equals n by n. Right. No, it's actually going to be 0, and we're going to check when it's n by n. Okay, and then so we're going to go, and then we need a directions array. Yeah. Perfect. Okay, and so our first direction is right. Right means 0, 1. Our second direction is down, which is 1, 0. Then our next direction is a left, right? So right, down, left, up. Okay, so this is right. We move the column. Down is move down the row. Left is 0, -1. And then we have up, which is -1, 0. So those are our directions. Now it's pretty straightforward. We literally just start at the first index and we keep going until we're filled. So we can just say while filled cells is less than n by n. Okay. We probably don't want to have it. We probably don't want to have to keep computing n by n, so we'll just call that capacity maybe. So, yeah. So we are going to write in the row, and then we are going to figure out, like, do we go to the next row or what? Okay. Yeah. Okay. So we're going to write in the row, so that's going to be matrix. We do need to have, like, a current row and a current column, right? So let's just do that. So row, column, equals 0, 0. Start at 0, 0. We're going to start over here. And then, so matrix, row, column, so equals, and then we do need also what number we're on. So technically, I guess this capacity thing, we don't actually need this filled cells and capacity because we just stop when our number is greater than n. So we'll just say like cur or something equals 1. Sure. So while cur is less than or equal to n, and then once we get to another number, we can stop. Okay. And we should always be able to, like, once we're going in one direction and we hit a wall, we should always be able to turn and reach a valid index. But here, we're not actually going to be able to do that. We're going to, like, hit a wall, and then we're going to turn here, but it doesn't matter because we're going to stop writing. Okay, I think that should work anyway. Yeah, because, like, what would a four-dimensional look like? We'd go here, we'd hit a wall, go here, hit a wall, go here, hit a wall, and then we would try to go back up here, but we would already be full. Okay, that's good. So this is cur. Now we have to get a new direction. We also need another variable like index, and that's going to be the index in directions that we're currently going. So if we hit a wall, then we need to update our index, right? So if we're going like here, for example, if we're going right and we hit a wall, then we need to go down instead and so on. But we only need to be turned once, I think. Okay, so let's just get n row and n column. So the new row and n column equals row plus directions, and it's going to be at index, so index, and that's going to be 0, and column plus directions, index 1. Okay, now we need to say if this is out of bounds or if we've already written here, then we turn. So if out of bounds, okay, so what would out of bounds be? Well, it's going to be n row is less than 0, or n row is oh, so this should not be n, this should be n squared. So yeah, I do want to calculate that. So let's just say full n squared. Okay, so if n row is greater than or equal to n, which is, yeah, okay, or n column is less than 0, we're out of bounds, or n column is greater than or equal to n. Okay, so these are the out of bounds conditions. Now we need to check, did we write in this column already? So, or matrix n row n column does not equal 0 means we wrote there because we initialized it all to zeros. Okay, so if that's the case, then we need to change the direction, and then we need to go that direction. And that direction should always be valid, I think. Yeah, we should only have one turn. So that's just going to be, so we're going to do index plus equals 1. And then we need to update these again. Okay. This is actually not index plus equals 1. This is index equals index plus 1 mod 4. Because, like, if we're at this last index, we need to go back to the start. So index plus 1 mod 4. Then we get a new column, fine. Now we try to write in it, right? Yeah. Yeah. Okay, so now we can actually, did we try to write in it? No. We, the cur is the value, okay. We actually wrote in it already. So we don't need to write in it, we just need to get the next one. Yeah. We need to update cur here as well. So we would like write the value 1, then we would update this to 2. We'd get a new place to go to. Yeah, and then we would go back. Yeah, it looks good. Then we return matrix here. Okay, let me just double check the work here. So matrix, fine. Direction, so right, down, left, up. Correct, right, down, left, up, yep. Index is going to be the index in directions that we are first going, which is going to be this one, yep. Cur is our starting value, row and columns are row and, yeah. Oh. One issue. Yeah. So we also need to update these. So that's going to be row, column, equals n row n column. So we do need to update them because we are actually writing here. Okay. Full should be fine. So so we write, we increment, then we try to go in the same direction as we could, and then if we're either out of bounds or if we've written in there before, just change direction one time, and then yeah, should be good. Okay, let's hope for the best. Nice. Okay. Yeah, so pretty straightforward problem. I think just pretty much just learn, like, know how to change directions and some easy stuff. I don't think it's super complicated. Definitely like a medium problem, nothing hard. Okay, so let's think of the time and space here. So we are going through the entire matrix. That's going to be n by n. And we do try two different directions, but that's just a constant time. So that's just like 2 times n by n. So fine. Space. It's n by n if you include our output variable, like our output matrix, but otherwise it's O of 1 because we didn't make anything other than the output matrix. So yeah. We can quickly take a look at the editorial just to make sure, but I think there's probably not a way better to do it. Yeah, traverse layer. Yeah, traverse. Yeah, so we just, I mean, yeah, n squared O1 if you don't count the res. Optimized ln squared O1. Yeah, okay. I think don't think you can do better than visiting each square once. Okay, so that's all for this problem, and this is where I'm going to stop this random problem series, and I'm going to come up with something new for you guys, and if you have any suggestions, then just write in the comments, and I would appreciate it. And if you like this video, please like and subscribe. It's going to help grow the channel. Thanks for watching, and I'll see you in the next video. Bye.